Hello students. Now in this session we will continue with the rest of the numerical models from the concept molarity. Right? Now suppose you are given with a question. Calculate molarity of 500 ml of solution. Calculate molarity of 500 ml of solution containing 500 ml of solution containing some 6.3 grams of oxalic acid. 6.3 grams of oxalic acid. This is one numerical given. For example, this is one numerical given. Now, on the same concept, see, let us take one more numerical. See, we have calculate molarity of 500 ml of solution, 500 ml of solution containing 500 ml of solution containing some 4.5 grams of oxalic acid. 4.5 grams of oxalic acid. There is a point of difference here between the two, because immediately whenever oxalic acid is given in the question, immediately we have to go to the point that types of oxalic acid. See, oxalic acid is of two types. One is anhydrous oxalic acid. One form is anhydrous oxalic acid and other form is hydrated oxalic acid. What are the two types of oxalic acids? One is anhydrous oxalic acid and other one is hydrated oxalic acid. Anhydrous oxalic acid means just a combination of two carboxylic acid groups, which is simply given as H2C2O4. If it is hydrated oxalic acid, it is along with the two carboxylic acid functional groups, 2 H2O molecule will be present as water of crystallization. For example, if it is a crystalline salt, right? In crystalline form. Now, it is given as H2C2O4 dot 2H2. Right? Now, there are two types of oxalic acids. If they won't specify the type of oxalic acid, then we have to go to their molar mass values. With respect to that, we have to assess the answer. For example, this molecular mass is 90. If you calculate 2 into 1 plus 12 is 24, 24 plus 2, 26 plus 16, 4, 64, 26 plus 64, 90. Whereas, this molecular mass is 90 plus, each water molecule is 18 grams, 2 into 18 grams, 90 plus 36, it is 126, right? So, we have to consider either 90 or 126. 90 corresponds to anhydrous oxalic acid and 126 corresponds to hydrated oxalic acid, right? Now, with respect to these values, we have to proceed by looking at the options. For example, you see, suppose here, find the molarity of this one oxalic acid solution. So, what is the formula? Mass of solute by gram molecular mass of solute into 1000 by volume is given in ml. I already told you that you should be perfect in all the relations, right? So this is volume is given in ml. Now let us substitute the values given. 6.3 grams of oxalic acid. 6.3 means what are the molecular mass of oxalic acid? Two types. H2C2O4 is 90. H2C2O4 dot 2H2O is 126. So usually 126 half value is 63. 126 half value is 63. This is one initial approach. Okay. It is 126 if you take into 1000 by volume is given in 500 ml. Right. So 6 point, this is cancelled by 2 times. 6.3 into 2. 12.6 by 126. It is 0.1 molar. The solution concentration is 0.1 molar. Now, when it comes to this numerical, it is 4.5 grams given. See, 4.5 grams is related to anhydrous oxalic acid. Okay. Now, in such a case, molarity equals to mass is 4.5 by molecular mass is 90 into 1000 by 500. 2 times. It is 9 by 90, 0.1 molar. Understood? So in this way, they may give, by mistake, if you do the calculation part, for this, if you take 90, or for this, if you take what is that, 126, you may get other value. That's why they will give options according to either anhydrous oxalic acid or hydrated form of oxalic acid. They won't give both. If they give both, they will specify the values. Hydrated or anhydrous, in that way they will specify the form. If they give anhydrous answer as well as hydrated answer, here it is coming as same, of course. If you take 126 here, answer will be different. If you take 90 here, answer will be different, right? Like that, if they want to include those two values also in the options, then they will specify either hydrated or anhydrous. So this is one of the areas where students must be very careful. You have to immediately notice with the numerical value, to which value it corresponds to. 90, 4.5, it is related, and 126, 6.3, like that. This is first approach, initial approach. Otherwise, anyhow, final values will have to justify, right? Now here, this molarity is 0.1 molar, and this one is also 0.1 molar. Understood? So this is the differentiation between anhydrous oxalic acid and hydrated oxalic acid. Now, let us solve one more question based on this oxalic acid thing. See, that question is calculate the mass of oxalic acid. Calculate mass of oxalic acid present in 100 ml of 100, take 500 ml. 500 ml of 0.05 molar solution. 0.05 molar solution. Understood? Now molarity of oxalic acid is given as 0.5. We are given with molarity as 0.05 molar. And mass of oxalic acid is asked. Mass of solute is asked to calculate. When solute is specified, we can find out its molecular mass. Now the question is, what's the molecular mass? What is the molecular mass? Right. So what is molecular mass of solute? So we have to try with both. Trial and error here. Gram molecular mass of first thing is anhydrous oxalic acid. What is the molecular mass of anhydrous oxalic acid, H2C2O4? It is 90. Whereas hydrated form of oxalic acid dot to H2O is 126. Right? Let us start with this 90. Then volume is given in ml as 500 ml, right? Okay, 500 ml. First suppose. Now molarity equals to mass we don't know by molecular mass 90 into 1000 by 500. Now this is cancelled by 2 times. Molarity is also given, it seems, right? 0.05. What is 0.05 corresponds to 1 by 20 molar. Right? 0.05 is nothing but 1 by 20. So we are taking it as 1 by 20. Now this is cancelled by 2 times. Mass of the solute is 90 by 20 into 2. Yes. Now answer option will be corresponding to this value. Suppose 9 by 4. What is the value? 9 by 4. I think it is 2.3. You solve it. Okay. 4 2s 8. And again 4 2s 8. And 4 5s 20. 2.25. 2.25 grams. One of the option will be with respect to this one. If it is hydrated form, molarity equals to, why to take the formula again? Molarity equals to, what is molarity? 1 by 20 equals to other form. We are calculating for hydrated oxalic acid. Molarity equals to mass we don't know. By molecular mass now we have to try with 126 into 1000 by 500. 2 times. So mass is equals to 126 by 20 into 2. It is, yes, 126 by 2 is 63. 63 by 2 is 31.5 by 10. It is 3.15 grams. As here, they did not specify the type of oxalic acid. anhydrous form or hydrated form. As they did not specify the type of oxalic acid, we have to go with the trial and error method. So option will be either this or that will be included. They won't include both, as I said earlier. They will include either 2.25 in among the 4 options or 3.15 among the 4 options. See the calculation part. Small calculation mistake may be there. Okay. Now maybe there is no mistake. Then according to this presentation of numerical, either they include this value or that value. They won't include both because they didn't specify. If they include both are possible answers. Understood? Even this point also we should be very careful. Right? Now mass of oxalic, suppose I am giving you the options. 2.25. Second one is 1.125. And the third option is 4.5. Fourth one is 9.0 grams. All are in grams. Then what will be the answer? If these are the options given in the question, what will be our answer? 2.25 grams. Instead, if it is given like 2.5 grams in first option and somewhere 3.15 grams in third option. See, now according to the options, this is our answer. Like that, they may include either hydrated form or anhydrous form. They won't include both values because they did not specify here. If they specify that mass of hydrated oxalic acid, then they can include both. Understood? Hydrated or anhydrous oxalic acid, then they can include both. If the type of oxalic acid is specified, both the values they will include. They will check the grasping and application of student. Okay, immediately whether students are going to the corresponding molar mass or not. So this is one area where students should be very careful in the calculation of mass or molarity with respect to oxalic acid, right? This is one question. And we have another important model in calculation of molarity. See, that part is calculate molarity of, see the question is, calculate molarity of 4% mass by volume of NaOH solution. 4% mass by volume of NaOH or 4% by volume. That is the way to pronounce this. 4%, see here, mass or weight. Both are because we are using the numerical value only. That's why we can use small m or w for mass here. Okay. I know there is a difference in the meaning actually between mass and weight. But as we are dealing with just the numerical value, we can use the symbol m, small m, or small w, and I prefer this w. You know why? In expressing molarity, we have another method called as in expressing concentration, we have another method called as molarity. Small m will be used there. If we use small m here for mass and their molarity is also small m, it may lead to confusion. Understood? To avoid that confusion, usually I am calling this as mass, but I am using the symbol weight, W. Got the difference? Now, suppose if a question is given like this. Calculate molarity of 4% by volume or 4% mass by volume of NaOH solution. Simply, they will give a question this way. Then how do we calculate? We have to expand the term. See, this is one of the presentation methods actually. Here we have two terms. Here also we have two terms. See, here also we have two terms. Now, assign first term for first, second for second. This is how to understand this term. Right, assign first for first, second for second. What is first? It is small w. See, this is small w, this is capital W. You can easily find the difference, right? Now, 4 is corresponding to small w, means 4 grams solute. Okay, now you have learned in NaOH solution, what is solute? Sodium hydroxide is a solute. 4 grams of solute, mass of solute is given as 4 grams. And what's the symbol corresponds to? percent. Percent. Cent means 100. This percent corresponds to V, means it is 100 ml. Volume of solution is 100 ml. Volume of solution is 100 ml. If you are taking this in grams, you have to take this in milliliters, kg or liters. Grams and milliliters, kg and liters. If they specify particularly volume is expressed in liters, then that's a different way. Okay. Otherwise, this should be taken in grams, this should be taken in milliliters or kg and liters. Right. Now we are given with mass of solute, volume of solution, and what is solute? Sodium hydroxide. Whenever solute is specified like this, we can directly calculate its molecular mass. Molecular mass of solute is sodium hydroxide 23 plus oxygen is 16 plus hydrogen is 1, that is 40. And then what we have to find? Molarity. What we have to find? Molarity. This is the question. This is step 1. What is step 2? Relating asked value, and this is molecular mass of solute, right? Gram molecular mass of solute, right? Now what is molarity? That's what we have to find. Formula between molarity and these terms is molarity equals to mass of solute by gram molecular mass of solute into 1000 by volume of solution in milliliters. Now substitute the values. What is mass? 4 out of molecular mass is 40 into 1000 by what is volume? 100 ml. It's 40 by 40. 40 by 40, that is 1 molar. Understood? What I did? Whenever x% by volume, x% mass by volume of solution is given, I assigned first term for first, second term for second term, as per the corresponding units. Then I observed the values and I noticed what to calculate. Relation between them is this one. I substituted the values. Simple. Right? But this method is for PU, not for competitive exams. This is a PU method. If you go on solving in this way in a competitive exam, see one point, I don't know whether you noticed or not. For these competitive exams, suppose NEET you consider first of all. 45 questions is given for chemistry. 45 minutes is the time allotment. So each question is allotted for 1 minute only. Even that 1 minute also we have to reduce because we have to save time for other subjects. Next to biology, chemistry is more scoring for NEET students. We have to save time for the other subjects, remaining subjects. To save time, we have to follow shortcuts. No, don't follow this lengthy method. Right? Even for JEE and advanced also, in single correct questions, etc. If you are lucky, they may ask. Right? But this part is useful in lengthy numericals. So instead of doing this lengthy procedure, I can give you one shortcut. That shortcut which helps you a lot is molarity equals to 10 into x by gram molecular mass of solute, of course. Molarity equals to 10x by gram molecular mass of solute, where x is percent by volume. What does x corresponds to here? Percent by volume. Whenever percent by volume of a solution is given, molarity can be calculated in one step using this shortcut. See now, for the same question, what is x percent by volume given? 4. What is x value given? 4. So, molarity equals to 10 into 4 by 40. What is that? 1 molar. One step. We can solve it in maximum 5 seconds if you know this shortcut. Understood? This is a systematic procedure and this is shortcut. Now, this is another numerical. See, calculate molarity of 9.8% by volume of H2SO4 solution. See, don't neglect this. Whenever this is the presentation, we have to pronounce this as some x% mass by volume or x% by volume. This can be or cannot be, need not be specified, right? X% by volume of solution means mass is compulsory, that's a fixed term. Mass or weight, whatever it is, right? So 9.8% by volume. Got the term? 9.8% by volume of H2SO4 solution. Even this also we will solve first in systematic procedure. Then we will continue with the shortcut, right? Which one you want? Yeah, usually students prefer shortcut. Okay, first we do in shortcut. See, what is molarity? Whenever percent by volume is given, how do you find molarity? It is 10 into x% by volume by gram molecular mass. That is 10 into 9.8 by what is gram molecular mass of solute in H2SO4 solution. Solute is H2SO4, right? Its molecular mass is 98. Already we calculated in the previous numericals. It is 1 molar. Yes. Now, systematic procedure also we have to get the same value. Let us now assign first term for first, second for second. What does it mean? 9.8 grams is the mass of solute. 9.8 grams is the mass of solute. Mass of solute is 9.8 grams. What is solute in this? Good. Sulfuric acid is the solute. Then, when solute is known, we can immediately go to its gram molecular mass. It is 98 grams. Right? Next, what is the volume of the solution given? Volume of the solution given, here percent is assigned here. So, volume of the solution is 100 ml. As it is in milliliters, I am using the small v. Right? Next, molarity is to be calculated. It's your turn. Molarity equals to mass of solute by gram molecular mass of solute into 1000 by volume of solution given in ml. So molarity equals to what is mass of solute? 9.8 by 98 into 1000 by 100. It is 98 by 98, 1 molar. See, instead of going through these many steps, in one step, 5 seconds, this is the best method for competitive exams, isn't it? Right? Now, these are the two questions, simple questions for this shortcut. So, what is X here? X is percent by volume. This mode of presentation is very, very important for students, right? What is X here? Percent by volume. So, whenever percent by volume of solution is given, I am repeating, whenever percent by volume of solution is given, molarity can be calculated as 10x by gram molecular mass. Molarity can be calculated as 10x by gram molecular mass, right? Now, another model. See, another model means just like we used the shortcut, see, 10x by gram molecular mass. Such technique, another such technique we are going to discuss now. See, the question is calculate molarity of 4.9% by mass. We discussed with volume, no? This time mass. Calculate molarity of 4.9% by mass or by weight, whatever it is. 4.9% by mass or percent by weight, H2SO4 solution. H2SO4 solution whose density is 1.1 grams per ml. Whose density is 1.1 grams per ml. Earlier, what's the method we used? Percent by volume. Now this time we are using percent by mass or percent by weight. See, both are similar. Once again, I am reminding you, in physics, really there is a lot of difference between mass and weight. There we have to deal with the actual definition. But in chemistry, as we are using just the numerical value, we can use the term. Okay, you please remember that point. Now 4.9% by mass of H2SO4 solution or 4.9% by weight of H2SO4 solution, right? Now, whenever such question is given, let us see the systematic procedure first. What is the density given? Density of solution. is 1.1 gram for every ml. Right? Means volume of every 1.1 gram is equal to 1 ml. Volume of every 1.1 gram is equal to 1 ml. When 1.1 gram is equal to 1 ml, 1.1 gram is equal to 1 ml, 100 ml is 100 grams, because how to understand this? 4.9 grams in 100 grams. What's the meaning of this? In the previous case also we studied the same. Assign first for first, second for second. No. 4.9 grams of solute. Are you following? 4.9 grams of solute is present in 100 grams of total solution. In total 100% means 100. In 100 grams of total solution, 4.9 grams is solute. Got it? Now 100 grams is the mass of solution. When 1.1 gram volume is 1 ml, 100 grams volume is how many ml? It is 100 by 1.1. That is, if you calculate, you will get it as 90.9 ml. What's the volume of the solution? 100 by 1.1 means 90.9 ml. So we are given with volume of the solution as 90.9 ml. We are given with the density, volume of the solution we calculated from the density, and then mass of the solute. Mass of the solute is 4.9. And what is gram molecular mass of solute? 98. Then what we have to find? Molarity. We have to determine what? Molarity. Molarity is the question mark. Right? Now, substitute in the formula. Molarity equals to mass by gram molecular mass into 1000 by volume of solution in ml. So, molarity equals to, what is the mass of solute? What is mass of solute here? 4.9. Out of what is molecular mass? 98. Into 1000 by 90.9. Right? Even we have to calculate this value also. So, it is 4.920s, 98. So 10 we can cancel. Molarity equals to 50 by 90.9. 50 by 90.9. Like it is 0.55, I think. It is, you can calculate this one, 0.55 molar, I think. That value on simplification. Right? Yes. Now, what's the value? Have you calculated? Is it the same? So, you immediately have to find the value. Now, the same question, find the value. Parallelly, you find the value. Now, the same question can be calculated using the shortcut. What's the shortcut for this? Shortcut is, it helps us to save time in competitive examination. Molarity equals to 10 into density into some Y by gram molecular mass. Here, what is this Y corresponds to? It is percent by mass of solution. Y corresponds to what? Percent by mass of solution. Now, let us apply this. Okay, I hope you all copied this part. Let us substitute here itself. See? Molarity equals to 10 into, what is density value? 1.1 into what is Y corresponds to? Percent by mass. What is percent by mass? 4.9 by 98. It is molarity equals to 49 by 98 into 1.1. Yes. So 49 twos. It is 1.1 by 2. What is 1.1 by 2? 0.55 molar. See, as I am explaining it to you, and you are the first learners, slowly we are doing. And more faster than your teacher, students can do the calculation part. That's frankly we have to agree, because your speed will be more than your teacher usually. So, this part of calculation you can do much faster. So, see, just by substituting in 5 to 10 seconds, we can get the same value for which we have crossed so many steps here. That's the advantage of shortcuts. So now once again let me repeat the relation here. See, shortcuts are very important and you should not forget. When, what's the point to be noted here? When percent by volume of solution is given, when percent by volume of solution is given, how do you find molarity? Yes, 10 into percent by volume by gram molecular mass of solute. Similarly, when percent by mass of solution is given, when percent by mass of solution is given, then how do you find molarity? 10 into density into percent by mass value by gram molecular mass of solute. These are much more useful, and even those application of these formulas also in another numerical. See, there may be some lengthy numericals where we have to use this term in to get calculations of corresponding molarity value in 2 seconds. In such numericals, these shortcuts helps us. Okay, we will discuss the rest of the numericals in our next class.